I am a furloughed employee, so I'm only here as Sunny the scientist, just representing the data sets and how we can utilize them going forward. I'm a pretty loud person, so I'm going to try to not scream into the microphone. So the other side of the house is I'm an Air Force forecaster by trade, so that's where I cut my teeth with weather. So what we're going to look at are some of the different operational ways to utilize weather information, different ways that we can make it more meaningful as far as utilizing AI, not just in the sense of being able to do model progs, but in the sense of how emergency managers and our stakeholders really need to comprehend the weather information. So we're going to start with something that's a little bit more challenging for people to grasp right off cuff. That AI is really already led in to help us kind of navigate as we go forward. So I'm going to shrink that. I need to figure out how to progress the slide. There we go. So what we're looking at here is automated sensor data. So across the US and in other countries, we have automated weather sensors we put in around World War II. And what that does is every 2 minutes, it takes a slice of the atmosphere at that location. So these are available open source, not just in the continental US, but internationally. We have access to sensors in China, in the Philippines, across the different southern hemisphere countries to include Australia and parts of South Africa. We also have quite a few access points across all of Europe. So when we're looking at different ways to make sense of data, what I did was I took all of this was with the help of an AI company called Kamiwaza. And what we did was we kind of laid out all of the ones we wanted within parameter for the continental US, because my notion was something's happening to the weather and it's not necessarily driven solely by heat. It's something that's a little bit larger than that. I believed that the low pressures and the high pressures, which control all of our weather phenomena at the surface, our rain, our snow, our tornadoes, our tropical cyclones, all of those are lows. The other side of the house, high pressure, that's your stagnant air advisories, your clear sky days, too much evaporation, drought, wildfire risks. All of that within these two buckets. And to say that the extremes were amplified on both ends there and by, it stood to reason that there was likely a greater disparity happening. So what we did was we trained it to understand the baseline average for the pressure at the surface. So anybody who's been a pilot at any point in their life, you understand altimeter and sea level pressure. From that, what we did was we kind of created this beautiful graphic that showcases the lows are indeed getting lower and the highs are getting higher than they were back in the 40s, 50s, 60s, 70s. There and by this point, what we're starting to see is this erratic pattern really kicking off more frequently. So not only are the weather events now empirically stronger in the sense of they're deeper, they're more potent, they're also more back-to-back. So this gives you that empirical nugget to move forward with your emergency managers. The other side of the house, and I know a lot of you are like, I can't say that, don't worry, I always make my PDFs available. What this means for all of our weather phenomena, if our lows are getting lower and our highs are getting higher, this means the area between will become more destructive. This means more winds, stronger winds, more prevailing winds as well. So Chinook, Santa Ana, Diablos for the west. Regionality winds across the east, an increase in our wind margin, which means more transmission line failures. It also means more drought. It means more of the precipitation that does come down will evaporate right back out again. So as we're starting to understand a little bit more about these upper level physics and how they impact us down at the surface, we've given graphics like these in the past to say, what is the next couple of months going to look like when it comes to energy planning, emergency planning? Here's every time somebody says La Nina, and they're like, I want to know, what does La Nina mean for me over the next couple of months? Honestly, I would say it doesn't mean a whole lot, because if you look at these graphics, a weak La Nina in many cases can come with variances depending on where you are in the continental US. It does mean that you're more likely to see colder temperatures, again, depending on where you are. When we look at the drought and the flash flood, they flip-flop back and forth depending on other conditions already primed. So these graphics aren't as helpful as I would like for them to be for our food and ag sector, for the energy sector, our water planners. So there and by, we needed something that was a little bit more robust than just being able to say one half of the US will get hit harder than the other half, that's it. So as we moved forward, we looked at things like the Farmer's Almanac. So a lot of people are very fond of the Farmer's Almanac, so we always want to make sure that we're utilizing all of the different data sources available to us, that we're not taking in any level of a bias. So from that, taking into consideration, does theirs match the La Nina lookout? Does it take in other factors that we weren't considering that we might need to ingest into our AI model? So when we're looking at this, we go all the way back, we go all the way forward, and we try to figure out how many were the driest, how many were the wettest, how many were the coldest, how many were the warmest, and we get these numbers just to be able to say, very similar to a groundhog predicting the end of winter, is that it's not very helpful for anybody. It just gives you something to kind of cling on to as you pay attention to the day-to-day weather phenomena anyway. What we really needed was the impact statements. So when we give weather forecasts to anybody, we say you're going to get 6 inches of rain. A lot of people's response is, that sounds like a lot, but I'm not 100% sure if it's damaging. And my response is, I wouldn't know. That's not my job. That is your job to understand what the forecast means for your operations. But there is a missing gap there, which is that if we don't know what they need to have, then we can't make those action statements in the forecast. Things like what we had with this most recent freak snowstorm event to the southern half of the United States. We had roof collapses because while the northern half of the US is rated and built for snow load, the southern half is not. So when we're looking at that, we are like, well, you know, what would have been really helpful is probably providing the graphic that we provide to the north about snow load and how much is too much for roofs. And then moving on, when we talk about transmission lines and ice buildup, a lot of them know that, but they don't know that if the winds get stronger, that you get what's called galloping, which will pull down the power lines at a greater rate. So we're able to communicate a bit better to say this winter our winds will be worse, which means whiteout conditions and blizzards are more frequent. Our ice storms will be more damaging because they'll be coming in diagonally. They'll weigh on things differently. So you're able to have that communication in a lot more meaningful of a way. But you needed to have this kind of comprehension as a forecaster to be able to do that. And that's a lot of extra work you're asking from an already overstressed and strained group as it is. So when we're looking at different ways to utilize some of the other companies that are out there, Climate Central has really come forward as a nonprofit taking on a lot of the different data sets that may not fall under the current federal administration's priorities. And from that, they're taking on the $1 billion disaster graphics. They're doing seasonality communications for the farmers. They do graphics that are applicable for marathon running. How does this impact your ability to go to national parks? How does this impact the baseball season? What about the start to school? Is there more need for air conditioning now? There and by, should we be having a better conversation with the energy managers to say, if we're going to be fluctuating when the school year starts, what would be best for the energy system, given that blackouts, brownouts would immediately take away our ability to send our kids to school? So when we're having these conversations, we're looking again at every data source that's available out there, being able to pull all of it in to make sense of some of the graphics, but not necessarily as helpful when we're talking about the now. These are helpful for planning for the future, but they're not helpful for where we're standing. So what I did was I wanted to showcase here just a quick review of where we're at when it comes to these weather sensors. So these are some of the most open line. I wonder if I can start it. Oh, marvelous, I can. So from this, what this is just an open platform. You can get to this on your phone, you can get to this on your computer. You can interact with every single one of these weather sensors to get a forecast. You can get a hindcast. You can get all of the climatological data for each one of these sites since that site was put in. From there, you're able to live interact. You can overlay radar within the continental US, but you can overlay satellite internationally. You can also look at some of the different weather patterns in the sense of storm reports if other countries are pouring in storm reports. So this creates an advocation for more data sharing just across the board. And as we play through it, you can just see as this will load in on the continental US, there's a big conversation that needs to happen when somebody says, I can use AI to do a better model forecast. Arguably, you cannot, because our models weren't great to begin with, and you're training a new model off of an old model that was known to be flawed. So if we're going to continue to move forward, I would prefer to see AI trained off of these data points to be able to say, as you interact with these graphics and you zoom in and you get to your area, you're able to data scrape by site to say winds have increased 15% at this particular location over the last 45 years. There and by, with the upcoming 5 years, if we flip that and add in that average, what do these weather events look like as a peak totality if conditions remain exactly the same? That's a better statement for our emergency managers. It brings it down to that hyperlocal level without having to downscale a model that was, again, known to be flawed and maybe they have heartburn about. So these are all the weather sensors that are available to you. So I never want to hear from somebody there's not enough weather data, because there's absolutely an insane amount of weather data. My computer crashed after this, if you were wondering, yes. And I have a very nice computer. So this was entirely for the purpose. You can see all the different parameters you can set. You can add on different layers. So in the live dashboard forecast, you can pull in this API. That's awesome. Being able to go in and interact with all of these different toggles, you can go and find every storm report that's ever been pushed for this location. How often is that happening? Is it record breaking? This is where we get those statistics that really hit the news channel cycles. So the other side of that, when we click on these graphics, what does this give us? Well, this gives us charts like this, which are helpful for me, but may not be helpful for an emergency manager, a stakeholder, an energy sector partner. What does that really tell us? It doesn't communicate that. It doesn't put it into plain text format or conversational format. It is a helpful graphic because you can see that the intensities increase during a particular window of time as far as the parameters I put in, which in this was peak wind events. So we have a really good understanding over the last X many days when they saw their peak winds, and thereby we can have that conversation with our emergency managers. Now, the other side of the house as we go forward is that this is another web page, the Iowa Environmental Mesonet. This is the repository of all things weather in the continental US and internationally. You can go to this page and you can find weather sensor information for pretty much any country that participates. We'll also look at Iceland will be a really good example. So as you can see going through here, you can find the entire month going all the way back. Look, it goes all the way, I believe, to the 1940s. So as 1930, 1940s. And it'll give you these parameters, which you can data scrape right off cuff if you would like. And it gives it to you in a month layout, which then gives you these graphics, which you're able to have any sort of interaction with. You can toggle on and off different parameters. And this just gives you a better understanding of different ways that we could utilize this weather information as we go forward. So when we're looking at this one, you can move over into these monthly summary tabs. And from this, it'll give you these very headache-oriented charts. Somebody loves Excel and is like, I can make this better. 100% you can. The whole point of this website is just to make it free, open access repository of information. So this is as much plain text data as they can host in an open format. All of it is attempting to grow in ways in which you can search. You'll see here that we'll toggle into other countries. You can go to different islands. I just like to advocate different good repositories like this. It's easy to train on and it's held by a university, which means it's also very easy to partner for best practice summaries. So as we go through some of this, I'll show you right after this how you can integrate this data into a PDF or an alerting system to say maybe you're talking with a chem sector site and they have benzene on property. What does benzene not like? Temperatures over 99, 102, 104. Propane doesn't like temperatures over 120. You could set up an alerting threshold. How many times has this area seen temperatures of that? How many times now going forward are we anticipating that? Should there be a propane farm in that area? That's a conversation nugget. The other side of the house, when we're looking at these and we're able to say total precipitation is increasing, we can then go to stakeholders and say, we note that this is happening. What are you looking to do about this going forward? Are we relocating? Are you putting in flood barrier systems? And that brings in the conversation with some of our just general, again, general topography information, but all of this information that you're able to pull, not necessarily inherent for everybody, but is something that is trainable to become useful. So this is really the big part of it, is just showcasing you guys the amount of raw data that's just sitting out there, primed and ready to be utilized. What we can do with these different plots, they've created a little chatbot on their page where you're able to interact with what is the historic National Weather Service chat. Not necessarily going the full scope, but when you see what the chatbot looks like, it has a very fond calling back to AOL back in the day. So as you can see, they're not investing a whole lot in making this the most usable. Their goal is just to show you different ways you could use it. So this, as a PDF guide, will be available to everybody so that you can click on the links, you can interact with the different repositories, and you can zoom in a little bit more to see how they sort of advocate utilizing the different National Weather Service parameters. All of these are different databases. So if you're like, I really want to know more about radar, I want to train my AI visually off of radar signatures to look for hook echoes so that it can automatically issue alerts for tornadoes. Awesome. They'll have that repository. What about wanting to train your AI model not for hurricane clouds, but maybe for the comma clouds, the big storm systems that come across the continental US? Maybe you want to train it just to look for the storms that punch through the atmosphere that have that dimpling on the surface. All of that's doable through satellite imagery. They have a major repository of that as well. So every time I get a conversation from somebody who says, I want to put AI into weather, the big part of it is this is honestly not being tapped the way that it should be. This should have been the first stop when we were doing AI and weather conversations, because this makes it more useful, not just in the continental US. This makes it useful internationally. And you don't get into the argument with an emergency manager on whether or not they like the NAM or the European or the GFS or the HRRR. Like, you don't have to do any of that. There are 26 weather models out there. And it's just crazy to think that anybody's showing up with an AI model that says, I made a new weather model. We have 26 of them and we can't get it fully down. I don't think we need 27, 28, 29. I would like to see ones that highlight maybe the difference between all of the models, to say, here are the parameters, worst case, best case scenario, based off of the GFS, the European, and the NAM combined. We already have some combined models, but to say that, I would like to see the difference. I don't want to see a new model. New models aren't as helpful because, again, they'll hallucinate the way that ours currently hallucinate. So again, looking at different ways that you could utilize the alerting systems, you can set this to say when temperatures exceed 105, send an alert to these emergency managers that we're looking for a benzene fire at these locations because benzene is stored outside here. We know that from a conversation with that stakeholder. Thereby, this was a concern they brought to the table. So you're able to immediately drill down and say, okay, what are some of our major concerns? Well, with extreme cold, you're looking at chlorine, you're looking at benzene as well. And you're looking at things like asbestos, the way that they interact with the temperatures, a big part of the conversation for the chem side. Extreme heat, mercury and lead that's left in any capacity in an external facing compartment or in a building that loses HVAC. That's another big part of it. If they lose power, what's on site that may be hazardous? The other side, when we're looking at some of the weather events that you could just flag for parameters, wildfires, flooding, drought, the major temperature swings. What material does not like a temperature spring? Of what we saw in Nebraska this past February, we had a 104-degree temperature spread between the lowest temperature and the highest temperature in about a week and a half. That's too much for most of our built infrastructure. Our wires don't like that, metal doesn't like that, concrete doesn't like it, it'll crack, it'll warp, it'll bend. So really what we're talking about is setting these parameters for comprehension. So this is a dashboard that we made for the Hazmat Summit utilizing AI, obviously. This pulls in some of those alerting thresholds. We created parameters for benzene, propane, and chlorine. And then what we did was we set alerts. I would like for you to alert me when it reaches X threshold. And because it's a demo, this looks an awful lot like something you could exercise. To say, hey, if your site saw this, I'm gonna just trigger off, what are your next steps? This will automatically produce a little safety query assistant that'll prompt your emergency manager, who is likely new to this problem set due to the mass exodus of emergency managers that we've had in recent years. This will likely prompt it in the right direction. Have you notified the National Operating Center? If so, did you say these things? If not, would you like for me to draft it and send it for you? That's a very easy solve because that's just a generic report. An alert has happened, there and by, here are concerns, we will report as it updates. So there's different ways that you can look at implementing this. You can also put in the site cameras. You can train AI off of different problem sets as your emergency manager interacts with it. Some different use cases when you get a PDF is that you can have it break it down by the different persons who are going to be looking at the problem set. So executive summaries for your executives, obviously just high level. We're concerned about this threshold being breached more frequently. It's already been breached twice this summer. The next breach may cause X impact, the end. The other side of it, for the hazard analysis, what are we going to do about it? What has been done historically? What are some other areas maybe considering doing? Can we lean on them? Who do we need to communicate to get funding for these kinds of things? What does a grant proposal look like if it is tied into a proper alerting threshold? So these are just different ways that you can utilize weather as we go forward. Looking at some of the other major problem sets, we know that extreme heat, while an impact to chemicals, absolutely water main failure. We know that water main failure usually occurs after a certain temperature threshold in most of these cities. It's either too hot or too cold and the pipe itself takes damage, or people need too much water. Thereby, that push-pull on the system ends up cracking it. So you're able to flag a lot of these events, and you could say things like, hey, we know that coal seam fires, which account for a lot of fires out west, coal is combustible as a natural resource when in temperatures over 105, can ignite, and from the ignition start a wildfire. Many of our large wildfires out west have come from a coal seam. This would allow some of our National Park Service to be able to flag, where are these coal seams that we're concerned about? Temperatures are over 105 in these pockets. I'm going to do some investigatory lean forward on that. Looking at a different way to consider weather information. This is a report that came out of Johns Hopkins, which is a major concern on my threshold because when I read it, and if I read anything in my voice, I assume other people can also, I read it as, if I'm going to do a cyber attack and I don't do it with a weather event, I'm dumb. And when you look at this, that's really legitimately what it says. I highlighted and read some of those statistics. Local economies could get a 37% drop in economic activity if you compound them. Why would you not if your goal is disruption? 37%. That would make me look like I'm not doing my job as a disruptor. So looking at this, different ways that they've already started in with it, different hurricanes, different things that if they were to couple this with hazmat sites, if they couple it with financial institutions, they've been doing this during the Olympics as well. So when we're looking at this as a major threat, just remember it's never just the weather event doing damage on the people, the site, the supply chain, the infrastructure. It's the other side of the house, which is that it adds in as a threat multiplier for other problem sets. So when we're talking about all of these concerns, don't worry, every country, like I mentioned, is going through it. So these are the headlines over the last 2 weeks. So just 2 weeks of headlines, things like what's going on in Antarctica? Why is it so warm there? That's not great for the ice. Other side of the house, we are noticing, I don't know if you guys have been tracking, but Russia's wheat crop failed. So this is a major problem set as we go forward. They're one of the top 3 producers. This is the second year that they've failed in a row. Other sides of the house, every storm that we see moves off and over to Europe. Every storm that makes it up and into Europe that's too strong, like Melissa right now, will move up and over to Europe and will disrupt all of the storms as they make their way over to the continental US, because our storms move like horses on a carousel in a continuous pattern across the northern hemisphere, which means a ripple in one impacts everybody. So it does not matter if we're abnormally warming or they're abnormally warming. It matters that anybody is abnormally warming or sees a major drop in pressure, like Melissa, who set a new record, making its way up and into that pattern set. So we are anticipating to see more problems like this come forward, which is why AI and weather are a notable couple that have to move forward, because we just don't have enough meteorologists, we don't have enough emergency managers, and there's just not enough comprehension of the correlation of the two as far as the impacts to being able to operate goes. So that was a really quick, I think 20 minutes max on every way in which I think that we should be utilizing weather going forward. This is a graphic to showcase to you guys that staying below the 1.5 degree margin's a dream, because over the last 2 years we've managed to stay above it globally. And if you wanted to get a hold of me, I am available on LinkedIn. I can also send the PDF over LinkedIn, which is fantastic. And with that, I don't know if I have time for questions, but that's, I believe, my time.
Would you like to take one? No, I'm loud. I'm loud. Maybe one question quickly and we'll jump in. I know you're a little bit late, so thank you, appreciate you. Any questions quickly? We can take one right here.
This is a little bit of an adjacent question, but can you talk a little bit about AI and sustainability? Like, is AI making all this worse?
Yes. So many of you may have seen the data centers most recently in Tennessee that Elon Musk has put into place that are running off of, I believe it's 38 diesel generators, and the pollution that's happened to the community downstream, and then their rebuttal against any new data centers. Subsequently, Virginia, a lot of requests coming in, hundreds of requests coming in for the DMV area for new data centers to come in to support the AI initiative. A lot of these are going to be moving into communities. They are going to be taking away trees. They're going to be overdeveloping into the region. There's a pro-con with all technological advancement to say that they did try to do submersing to see if that would help with cooling. They've tried to do different types of cooling to maybe not need water as much for the evaporative side or for any of the run through just on energy. The downside is that for what we anticipate the need to be, we do not have the efficiency scaled at that rate, I would say, just based off of the different reports that I've seen on water use that come out from every different AI company, as far as both them and the energy side. Cryptocurrency is also using a ton of water. It's often buddied up against major lakes, rivers, and reservoirs. That produces another issue where when you pull water out of a resource, you heat it, and then you put it back in, it does evaporate out a lot faster. So we end up with a twofold. It's not just the demand on the water resource and the land resource, it's also the cascading impact. So while we have great use cases, if it's going to be utilized anyway, this is my main advocation, is using it smart instead of running models over and over and over again. This makes a lot more sense. But to say, I am also very hesitant about who's coming into the AI sector, who's coming into the data center sector because of those damages, and that we're not modeling them properly. Who's tapping into the aquifer? How are they attaching into our public systems? That should be a more honest dialogue, because if we can't all be aware of that impact, then we can't help to mitigate it. So if anybody's looking at starting into that, I would recommend coming to the table with open arms, wanting to bring in the technology and have the conversation about sustainably building into the community, not showing up and doing a land grab and saying, I'm going to build here now, because the community will buck against it.
Thank you. You were amazing. I can't believe you literally just jumped off a plane, jumped on stage, ran in here, dropped her bags, and delivered a presentation like that. Thanks so much.